Okay, welcome to our second panel discussion this morning on stencils and avoiding printing defects. Of course, the stencil or the printing process is still accounting for 60 to 70% of all manufacturing defects. And here to discuss this and some of the best practices we can use to help avoid them is our panel today, which I'm joined to my extreme left by Laszlo Gilog from ASM. And then to his right, we have Richard Boyle from Henkel. Welcome, Richard. To my right here, we have Fraser Shaw from Tanlin, stencil manufacturer, stencil company. And then to my extreme right, we have, let me get this right, Corne Hoppenbrouwers, perfect, from Alpha. So welcome, gentlemen. Pleasure to have you all here. So let's start off to my left here with Laszlo. Is insufficient paste the #1 print-related defect?
Well, it's yes and no. So it's yeah. In our experience, insufficiency play a very major role in the print defects. But in these days, with the miniaturization, when the components getting smaller and smaller, you have less interspacing. The package is much smaller. I think it's equally important is the imbalance of the solder deposit between the copper pads.
Okay. So the volume of the paste between the copper and the pads?
Exactly.
Okay.
Exactly. Still the major issue is the insufficiency, but in these days with miniaturized PCB, we also see together insufficiency and bridging or excessive heights together.
Okay. Richard, obviously miniaturization is causing more and more issues, but insufficient paste is still really, one of the major issues, I think, with the...
I think given the opportunity, people can get many defects with printing on the system. I think if you can choose or work together with your stencil producer, stencil designer, your PCB producer, and your paste supplier, you can get very, very good results. And certainly from a paste producer point of view, I know that the trend that we all have is to try and produce solder paste now that can overcome the issue of having to work to the aspect ratio of 0.66. And I know that we're all looking to produce materials that can print down to smaller and smaller aspect ratios.
Right.
Some cases, aspect ratios of 0.5 are achievable, and even lower. And certainly with some of the modifications that some of the equipment companies have had with the vacuuming of the PCBs to hold them completely flat, with the vibrating squeegees and with other things that you can do on stencils now, you can overcome some of those insufficiencies that you might have had previously.
Right, okay. Fraser, as a stencil manufacturer, I mean, what's your approach to the insufficient paste issue? I mean, is it cutting trapezoidal apertures, or what would be your approach to it?
Well, first, trapezoidal apertures went out with the arc, I'm afraid.
Did it? Okay. I am rather old, you know.
We're all quite old. But I mean, as already been said, it's about getting the right volume.
Right.
Tailoring the stencil to give the right volume for the component in question. And what we're seeing is more and more, we're seeing a phenomenal increase in the use of multi-level stencils. It's getting the right foil thickness for the component that you're trying to print. That is the way to reduce the defects, definitely. Okay.
And of course, but are you aware of what type of paste the customer is using with the stencil?
Yeah, we'd have a library of modifications for every customer, and sometimes every engineer within a customer. And within that library, we'll have details of which paste they're using, what kind of printer they have, what kind of modifications they like to avoid defects. So we store all that data, Yeah,
okay. Corne, how do you handle the insufficient paste? Do you have anything to add to the discussion already?
Yeah, first I would like to thank you for the opportunity to be here, because I think most of the customers doesn't know that Alpha also produce stencils and absolutely know everything about developing a paste. So let me put that forward. Secondly, if something goes wrong, paste has the blame. 60% on the end. Also, Alpha is globally the biggest stencil supplier and have a big database. Coming to your question, we see a few things, and the one that I'm aiming for is that we see a bigger mix of smaller and big components. And that makes the challenge of a good paste release today more and more important.
Mm-hmm. That's right. I mean, it's not just the miniaturization, it's the actual combination of smaller devices next to larger devices.
Well, what I can add to that, 5 years ago we saw something like 1,500 apertures in a stencil. Mm-hmm. Today it are 3,000, and it means that as the squeegee moves over the stencil, it's pulling more and more. Mm-hmm. And more apertures means that the board, the paste, sticks to the stencil, so when it releases, it just bounces. Right. Meaning that you have to go to higher tensions to eliminate the defects of printing.
Right, okay. No, you're right. So let's move back to Laszlo at this end. Obviously, we've talked about insufficient paste, but there's a number of different defects that can occur in the stencil printing process. What are the other difficult ones that you have to deal with? Let's discuss some of other types of defects.
So it's usually what we see on the PCB is insufficiencies with bridging, or even if you look the SPI side, we have SPIs working between limits. Yeah, they have low limit, they have a high limit, and different components, different packages probably need different threshold levels. Mm-hmm. More tighter tolerances, and this is something, for example, in our portfolio we have Process Expert. This is a proactive system. It is also optimizing the process, because usually in the production you start with one settings, then you have the stencil, you optimize the stencil, and during the production maybe some parameters are changing. Our system is a proactive system, so it can modify the settings, and it can
it can correct it.
Yeah, it can correct it. Yeah.
Okay.
And back to the insufficiency, we also have solutions like surface treatments, like coating solution. It is helping the paste release. It is also improving the throughput, so you don't need to clean as much often, and the paste release is much easier, much better. Yeah. So on PCB level, with these components, when big components, small components is near each other, a lot of problem caused by the substrate level. So the substrate on the PCB, you have seal screen print, you have solder mask, and these things, these unevenness on the PCB is putting out the stencil from contact position. And one basic thing with the solder paste printing is to have a zero gasketing. Mm-hmm. And all of these challenges, if you have 20-30 micron gap between the bottom side of the stencil and the pad where you need to print, that is making a big challenge. And for example, the coating is helping to overcome on this challenge. Because the solder paste, when we print the solder paste is not getting just vertically down to the pad. It is spreading on the bottom side of the stencil. Yes. And the coating is just stopping this flux to smear on the bottom of the stencil, so you don't need to clean as much often. Also, some of the coatings having some effect on the bottom side of the stencil, but also equally important is the inner side of the aperture wall. To make it more flat, to reduce the adhesion between the flux package and the aperture sidewall, just to have a much smoother and much easier release.
Yeah. Okay. Richard, a lot of different processes competing with each other, creating a lot of different issues. What is your view on this?
I always look at it as an opportunity.
Yep.
You can get a lot of the competing, as you say, between. And we see a lot of issues with board stretch, with batch-to-batch variation in the PCB, where the pads actually end up compared to where the fiducials are. I would agree that the gasket in the way that the stencil connects with the PCB can be an issue, especially with the ultra-fine pitch and very fast printing. What we've tried to get some of our customers to do with that is to use some of their via holes or some of their connecting holes that are all the way through the board, to try and design the nesting table that they have to have a vacuum point under those holes so that when the stencil comes down, it sucks the stencil onto the PCB, which removes any of that risk of variation in the gasketing, because it's actually helping to hold it down.
Hold it in place. That's a good idea.
That can then give you that lovely springing effect as you take the stencil away, which helps with the paste release. So that's a very simple fix that people can do to overcome if they see a warpage in the board, if they have some issues. Get the nesting table, get the vacuum in the right place, get some holes that are already in the PCB, suck that stencil down. That kind of works. There's other things you can do. There's lots of little tricks you can do to try and overcome some of the day-to-day maintenance issues that you might see. But I don't see it as a conflict. I always see it as an opportunity and a potential to work together as a group to overcome a lot of these solutions. Yeah. I'm thinking stretching is a problem with the boards and CTE mismatches and all these things. Always, it's always fantastic. The variations that you can get you'd be surprised some of the changes that occur just by changing to a different supplier or looking at anything else on the PCB. Yeah, I'm sure.
I agree. So it's printing relatively very simple. So you need to print the right amount of solder paste into the right place with a good repetition. So it's
that's true. Fraser, I mean, making sure the stencil is held in place is obviously critical. Systems for retaining it. Do you work with your customers to
Yeah, absolutely. I mean, just to echo what the guys have said there, we have some of our very highest end customers. We will measure the step and repeat on a circuit board to see how bad it is, because it's never perfect. I guarantee that it's not going to be correct. And we will make the stencil fit the circuit board. And sometimes it's from batch to batch. So if you have a very high-end application where you need to get perfect registration, change the stencil to suit the circuit board.
It's going to vary, isn't it, every time, depending on how they bake the boards and all sorts of things.
It will. But one thing's guaranteed, it's never what it's meant to be. It's always going to be wrong. So if you have that opportunity, then it's worth doing.
Right, okay. Corne, what is your view on this?
Even we are talking about a metal plate with holes, right? In principle, it's a lot more. As I said before, the customer has his board, he has the printer, he has the paste qualified, and if there is a problem, the only way you can play and solve the issue is by stencil change and design. I'm personally not so worried about a little bit shifting, because if you do pin and paste, you overprint and it will withdraw back anyway. But more important is that you find the right way to define the aperture for every component. And what we see quite a lot is avoiding, as they try with changing the profile. That helps only 2-3%, but stencil you can change the voiding result with 50%. So the whole combination of a right design, desire of meeting particular specs, shorts, paste release, consistency on an array component, makes the stencil a lot more than just a metal plate with holes.
Yeah, absolutely. So we've established the fact that there's a myriad of issues can go wrong here. And given the complexity of all that, is it possible to mitigate some of this in the future with automation? Because our industry is moving towards greater automation and less, fewer operators on the line, etc. Is this something that we can automate better?
Yes, that's the way forward. So that's what we are doing at ASM, automation in every level. So we are offering solutions for every aspect about the printing. So we have just now we released DFM Health Check, for example, which is a special option on the SPI, which is trying to take out some of the automation from the design part. It is not going to design the stencil, but it is an automated check, which is considered not just the stencil design, but it's considering also about the machine settings, because this is another thing. So Fraser can, I think, surely he can cover me. A lot of time when we design a stencil, we are working from Gerber data, and a lot of time what you see in the Gerber data is not the same as you can see on the PCB.
Yeah.
After that, there are a lot of other variations, like solder paste, the machine settings, what are the tools, what are the options, what you use on the printer. So, for example, in the DFM health check, we are covering and we are considering about these factors as well.
Yeah.
Or inside, in the production environment. Or it depends on how much is the solder paste roll, which is rolling on the stencil. So all of these kind of small steps is helping and automated the process. Like we have the paste management systems, paste roll height monitor, automatic paste dispensers. We trigger the cleaning through the SPI just in time and proactively before the defects is happening on the.
Yeah, so you have a number of corrective things built into your printer. Talking about using automation to improve it through SPIs, most of these SPI systems at the moment are really just adjusting the offsets. They're not doing a lot more than that at this point.
There's certainly with the bigger implementation of Industry 4.0. Everyone loves to talk about it. There is potential there for not only getting the SPI to look at the offsets, but also to introduce change in the speed of the print, maybe looking at increasing, lowering the pressure. But also in time to come, there will be, and it's a different topic to stencils, but there will be an opportunity to have maybe a jetting system after the SPI to add extra paste.
Yeah.
Or to correct some of those defects where there is insufficient, where if you haven't invested in a step stencil or the ability to have a step stencil means that if you have a very large pad, very high volume of solder paste, but beside that you need a very small component, the jetting system may be able to add extra dots after the print process.
Right.
But I think with the way that the industry is going, I think you're right, automation will become more and more. And I think the implementation of all of those aspects where your SPI has positive feedback to your printing, the design, the better use of step stenciling to get more diversity on a PCB, I think we can overcome a lot of the issues that we're actually seeing now.
Absolutely. But I mean, using your idea of using the jet dispenser after the stencil printer, that's really just putting us into a rework situation there.
Absolutely. Yeah. And it's identifying that
an expensive one
unfortunately
too.
There's going to be an issue at some point where, and it's maybe not today, maybe not tomorrow, but in years to come, if we continue to look at the miniaturization of components, the miniaturization of pads, there's going to be a limit where your stencil is going to have to be 50 microns thick on some of those apertures, but might have to be 120 microns thick on some of the bigger ones.
Right.
And there comes a limit. I think we can still do it with stencils, but there will become a limit if we continue down the path of miniaturization. If we don't embed those devices within the PCB, we may have an issue where we will have to have a system. It could be pin transfer, it could be anything that adds a little bit of paste to some of those pads that we just can't print.
Right. Fraser, as a stencil manufacturer, I mean, are you getting involved in the automation debate at all? Are you consulted on it? Are you working on it?
No, absolutely not. I mean, we brought up the issue of data control and how you use that data, how you use the SPI data is paramount. And I find it remarkable that there are still so many people that are, in Scotland we would call it hand-knitted designs for stencils, but to the rest of the world it just means that someone is looking at a list of modifications to make to a stencil and applying them and trying not to forget to do the modification. I think that is something that is a big source of defects in stencil manufacture.
Right.
As a stencil manufacturer, I know the number one problem with stencils is that the CAD guy screwed up.
Yep.
That's it. That's what goes wrong with stencils. The laser machines very rarely screw up if you buy a good one. It's a pretty faultless process, but the CAD guys do screw up if you let them go through a manual list of modifications to be made for customer A, and then they get a new manual list for customer B, and they go through it manually. And that still happens in a lot of stencil houses across the world. So if you automate that, then you take away a huge source of error. The other thing is that I still think very few people are taking that SPI data and closing the loop back round to stencil design.
Right.
That's not happening enough. People aren't doing enough of it. You know, the very advanced manufacturers are doing it. They will constantly be reviewing their design guidelines for a stencil.
Right.
But I'll be honest, probably 80-90% of customers don't bother to do it. They just stick with the mods that they've always done, and they make them work.
Right.
So it's an opportunity.
Yeah, definitely. So you really, you know, it's rubbish in, rubbish out, basically. But you know, some of the software companies we've been talking to this week, though, are actually closing that DFM loop, and that's going to be huge.
Yeah. Yes,
so rather than having products doing 5 or 6 turns before we get them into production,
correct.
the information's going right back to the designer, and he's getting it right on the first
And it's not
pass.
like the components are changing every time you build a new product. It's the same components every single time.
Yeah.
You should be able to arrive at designs that work for that component.
Right.
With
Right.
more or
Absolutely.
less, not exactly, more or
Have
less.
you never spoken to the purchasing department that suddenly buys a slightly different component without telling anyone?
Well, we all know that if you added up all the tolerances in a circuit board, it's impossible to make. But within those limits, then they are at least similar. Yes.
Yeah. Okay. Hornet, do you get involved more in trying to advise or work with the people trying to automate the process? Do you think automation is going to help drive out a lot more of these defects?
Yes, but coming to defect, I agree with the fact how you have to design a good stencil. And when there is a problem, and luckily Alpha changed its name in Assembly Solution because we offer a solution. And the solution is not only the product, the stencil, tension system and so on, but what I see in the practice, and I'll say also can confirm, like I confirm to them, is when you look at the stencil at a line, the apertures are 10 centimeters, and the scratched area where the squeezy move forward is 25. It's like a needle with a hammer like that. And you apply too much squeeze pressure, you damage your stencil, stencil is banned, you get a very uncontrolled release. So we did a great job altogether, and the defects come to the fact that operators don't treat the stencil correctly, and that's also why I give very often SMD good practice trainings to the engineers, because we can make the best product, performs perfectly in the beginning, and after I
But
say
if it's not applied
10,
properly,
yeah,
then
it fails.
Yeah.
And again, pace gets the blame.
Right. So more training, better training of operators on how to handle and use stencils. I think that's an important point. Okay, sticking on the paste side, which of course is your mainstream.
Finally, we're there.
What about paste storage? I mean, that is an issue that's been talked about. Does that have an effect on the quality as well?
Yes and no. I know there are stencil paste supplies that say for a year, but I think if you have to buy paste and you put it for a year in your refrigerator, something is not logic to me. We are going and we see moving to 4, 4.5, even type 5 powders, where the chemistry is very demanding on the performance, reflowing, voiding, and so on and on. If you look at the chemistry, it becomes so complex that it is normal to expect that the customer treats your product correctly and that they keep it in the best condition to perform in the best way, meaning respecting the shelf life in which we guarantee 100% for all products, for all components and all specs, printing speed, release and so on, that what we promise will be delivered.
Right. Okay. Well, Richard, I know you have long storage life products. Is there a trade-off in quality with the length of life?
Hopefully not. The aim we have is to try and make the products as robust as possible, to try and take out some of the influence we might have on handling, on the way the paste is used. The ultimate goal we want customers to do is to not scrap any paste. So we're looking at ways where the paste can be left on the stencil and just continually add to it, whatever the situation is. So we want customers who can, even in very low frequency, short production runs, not throw away the paste at the end. So the reason we're developing the products that are room temperature stable is not just so you don't have to put them in a fridge.
Right.
I know that was the advertising that was initially done, but it's not aimed at that. The real goal, the real benefit of it is that you can leave that paste on the stencil forever.
Right.
and use 95% of the paste you buy rather than scrap the paste at the end of each shift.
Yeah.
So we're trying to take away some of that variation that the operator might have to try and make the materials as robust as possible. But that's, again, that's to try and make life a lot easier for the future. You know, so it's a long-term goal to try and achieve the best results as possible. We're doing that now by making it as robust as possible.
Right.
And again, everyone's moving to type 4, type 4.5, type 5. We find with the products that we're developing now that have that really good aspect ratio release, we can use a type 4 where maybe other people might be using a type 5. That makes it easier to produce, makes it cheaper for the customer, and reduces the issues within reflow.
Right, right. Okay, well, that makes sense. Laszlo, let's go back to the stencil printer side of it for a moment. Cleaning cycles for cleaning the stencil. How often should we be doing that, and what is the most effective way of stencil cleaning?
This is a very good question. So I think in these days there is no good recipe at the moment, because the board, at the end, the board will dictate how often you need to clean. If you have a good board with you can achieve a zero gasketing between the stencil and the print. You are going to clean less. If you use a coating, you are going to clean less. If you are not using coating technology, or if you have a bad PCB where the gasket is really big, it really depends on how big is this gasketing, how good is the printing, what is the squeegee pressure, how you manage the solder paste, how the solder paste is rolling in front of the squeegee, what is the squeegee what you use. So there are a lot of factors which is influencing the cleaning. Also, from the cleaner side, what is the cleaning roll what you use? There are for a lot of people, using cleaning roll is just a piece of material. So all the different cleaning rolls can do some job, but it's not equally doing some job.
No.
Within ASM, we are focusing also for harmonizing our products. So if you have a coating technology, for example, we offer a cleaning roll which is not abrading the coating. So it's not putting mechanical abrasion onto the stencil. From the cleaner side, we know that the cleaning takes time, so it has a huge impact on the cycle time. Yeah. So we have a hardware solution also to reduce these cleaning cycles. Also, the solvent is very important. How the solvent, what is the compatibility of the solvent with the solder paste? Right. How effectively it cleans it, because all of these influencing the paste release. If you clean the stencil, if you can keep the stencil, bottom side of the stencil clean, everything is getting much easier. Right.
That's true, but and as Laszlo mentioned there, the interaction with the solder paste and the cleaning cycle is very important too. But some of these cleaning rolls give off lint or small amounts.
Exactly.
So you have to be very careful for that. There's also some people are using ultrasonic cleaning, but that may or may not have issues as well. What's your view on it, Richard?
Everyone's different. Everyone has a different process. Everyone looks at things in different ways. I would say if you can get a good quality under stencil wipe, which is completely lint-free, you may or may not want to use a solvent clean at that point. I'm not a big fan of solvent cleaning as an under stencil wipe. I'd rather do dry and vacuum. You can have ultrasonics, you can have lots of things. In an ideal world, you wouldn't have to clean anything. Right. But in the situation we have now, I would say, depending on the quality of the board, depending on what you needed to do, you may need to actually clean each PCB as it goes into the printer using rolls or vacuum cleaning. You may have to use an under stencil wipe every PCB. But there are occasions where people will do an under stencil wipe every 50 boards. So it is dependent really on the process that you're running, and on the gasketing, and on the setup, and on what's going on. So every production line is different, which is great, because that means I have a job.
Of course. I think you'll have a job for a very long time, Richard. Fraser, I mean, nano coatings, how much easier does that make for paste release and for keeping and for helping with the cleaning process?
Well, I would say that the jury is still out a little bit on this, and most of the information that we have is empirical on nanocoatings. I mean, there have been some studies done, but there's never been the kind of overarching study that says, here's the result, and this is it's an absolute slam dunk.
Right.
The reason for that is, unless you're doing something pretty difficult, the nanocoating might not do an awful lot of good, or might not be perceived to be doing an awful lot of good. I'm sure you will get better results, but the overarching conclusion from a lot of our customers is a standard stencil is good enough.
Right.
And it might not be true. They might save money by using a nanocoating to improve their printing somewhat. That is probably the case, but I would say the industry in general, less than 50% are using nanocoatings. It's getting more and more and more, and those people who use it like it, and it does improve their process. But the jury is still a little bit out on it.
Right, okay. Courtney, last word to you. We're starting to run out of time. Nanocoatings, I mean, they differ in quality. Some of them last so many cycles. Some of them they claim are permanent. What is your view?
Personally, I'm not so in nanocoating. We were talking about cleaning, and yes, if you have nanocoating, the stencil will clean a little bit better. I don't know, perhaps I'm too practical, but my experience is if we are talking about cleaning, the first step is that you have to be sure that your machine is cleaning your stencil correctly. Yeah. My experience, over 80% from the customers take a permanent marker, open up, make a cross in a box, do an underwipe cleaning, and you will see the cross is still there.
Yeah. Okay.
No, it's not a joke. It's really
it's practical.
So fix that first, and put the right squeezy pressure, right size, right pressure. Keep the stencil flat, and then you can reduce the underwipe, and the result of the underwipe much better, and you have a lot less defects.
Great. Okay. Well, gentlemen, unfortunately, we're running right out of time. It's a huge topic, and we'll certainly come back to it many times in the future. But for now, I want to thank our panel. Laszlo Georg on the end from ASM, Richard Boyle from Henkel, Fraser Shaw from Tanlin, and of course, Cornelia Hoppenbrauer from Alpha. Okay. And thank you for joining us today.